Hello everyone. In this class, we are going to study about trigonometrical ratios of class 9 chapter 17 ICSE syllabus. Now, after completing this class, you should be able to understand the meaning of the term trigonometry and identify different trigonometrical ratios, as well as you should be able to identify the type of identity you are going to use to solve a particular problem. Okay. Trigonometry is derived from the Greek words, which basically is decrypted in three parts. Tri, which means three. Then we have gon, which means sides. And then we have metron, that means measures. Okay, that it's basically the relationship study of relationship between the sides and the angles of a triangle. Sides and angles relationships of a triangle. These ratios of the relationships between the sides and the angles were used by earlier astronomers to find the distance between the planets and stars, distance between planets and stars from the Earth. Okay, that was the use. Okay, used by astronomers. Trigonometry deals with all types of triangles, but this chapter of class 9 deals with only the study of the ratio of sides of right triangle with respect to the acute angles. So in this class we are going to deal with right angled triangles. That's right triangle, and its ratios of sides. You all are familiar with the term ratio, as you have learned this in previous classes, which means comparison of similar type of quantities. Okay, similar type, that means if I say you're going to compare 5 kg to 500 gram, since the units are same, you can cancel them. That means 10 times the first one. So if you compare the first quantity is 10 times the second quantity, and that's the ratio 10:1, and no unit. So ratio has no unit, as you are comparing two quantities of same type. Now let us consider a right triangle. Let us name the triangle. This vertex be A, this one be B, and the third vertex be C. And the angle at this point, vertex B, is 90 degrees. Okay, so we are taking a right triangle. Which means there is at least one right angle 90 degree. Okay, now let us take one of the other two angles as theta. So we can write what are the vertices. There are three vertices A, B, C. Angles. So there are three angles again. One is theta. We can write that's ACB. Angle ACB. Then we have ABC, that's 90 degree. And the third angle is BAC. Okay. You can also write CAB. So now the sides. We have three vertices, three angles and three sides. AB, BC and AC. If I ask you how many ratios you can find taking two sides at a time, and there in total you have three sides. Okay, let's start. Suppose we take the first ratio as AB by AC. Okay. Now the second one as BC by AC. And the third one AB by BC. Any other ratios possible? Yes, we can take the invert of all these ratios. So we have again AC by AB, then AC by BC, BC by AB. Any other ratios? It is not possible because if you take two sides at a time and there are in total three sides, so at the most you can have six ratios. So these are the six ratios, and this chapter deals with those six ratios, trigonometrical ratios of sides of a right angle triangle. When you compare these ratios with respect to this angle, angle C, or we have named it as theta. So with the respect of this angle, this first ratio is known as sine theta. Okay, so sine theta is AB by AC. So that's perpendicular, or you can say that's opposite. This side is opposite to this angle, so we can say opposite, and AC is the hypotenuse of the right angle triangle, so that's hypotenuse. That's opposite by hypotenuse. Okay, so sine theta can be in short written as sine theta. Okay, now the second ratio is, this one is adjacent to this angle, so that's adjacent to the angle theta, and we have cosine theta. Okay, cosine theta. So in short we write cos theta. That's adjacent by hypotenuse. The third one is tangent of this theta. This ratio is known as tangent of the angle theta. In short we write tan theta, and this is opposite by adjacent. Okay, now I hope you understood these three ratios. This one is sine theta, this ratio is sine theta, this ratio is cos theta, and this ratio is tan theta. Now the inverse of these ratios, that's inverse means hypotenuse by opposite, this is cosec theta or cosecant theta. In short, we write cosec theta. This one is hypotenuse by adjacent. The inverse of cos theta is sec theta. Okay. Secant theta, in short we write sec theta. And the last one is cotangent, in short we write cot theta. Okay. That's adjacent by opposite. So if we write all the ratios at one place, we have sin theta equals to opposite by hypotenuse, or in some books you may find it as perpendicular by hypotenuse. Then cos theta, we have adjacent by hypotenuse. In some books you might find it base by hypotenuse. Then tan theta equals to opposite by adjacent. In some books it's perpendicular by base. Okay, and the inverse of these ratios, cosec theta, is the inverse of this, that's hypotenuse by opposite, that's hypotenuse by perpendicular. Sec theta is hypotenuse by adjacent, that's hypotenuse by base. And the last one, cot theta or cotangent theta, is adjacent by opposite or base by perpendicular. And the identities, there are some identities related with these ratios. Okay, so you're going to remember this. There is one short trick to remember this. Basically, we write all these sides at one place, say opposite. So we can write all these ratios here, opposite by hypotenuse, then we have adjacent by hypotenuse, and we have opposite by adjacent. So the first one, is sin theta, that's opposite by hypotenuse. Then we have cos theta, that's adjacent by hypotenuse. Then we have tan theta, that's opposite by adjacent, and the inverse of tan theta is cot theta. Then inverse of cos theta is sec theta. Sec theta is hypotenuse by adjacent, and cosec theta is hypotenuse by opposite. Okay, so this is the short way to remember OA, OA and HH. Okay, so you can also remember another one, that's with those P and B, perpendicular and base. So that's Pandit Badri Prasad Bole Hari Hari. This is just a trick or shortcut to remember. Remember, you can always find your own tricks to remember particular things. Okay, so this is sin, cos, tan, then cot, sec and cosec. Okay, now let us see what is meant by reciprocal ratios. We've already seen that in the previous part, that sin theta reciprocal is cosec theta. Okay, so the reciprocal of sin theta is cosec theta. Sin theta is opposite by hypotenuse, so cosec theta is then cos theta is reciprocal of sec theta, and tan theta is the reciprocal of cot theta. Okay, so these are the reciprocal ratios or identities we have. We can remember this. We can also write it in other format, like taking the cross multiplication, we get sin theta into cosec theta equals to 1, and cos theta into sec theta equals to 1, tan theta into cot theta equals to 1. So whether you remember this or this, it means the same thing. Now let us see quotient ratios. So sin theta upon cos theta means sin theta, if you remember, that's opposite by hypotenuse, and cos theta is adjacent by hypotenuse. Okay, so that's if you do it, opposite by hypotenuse divided by adjacent by hypotenuse, that's opposite by hypotenuse into hypotenuse by adjacent. So you get opposite by adjacent, and that means tan theta. So this is the first relation, tan theta equals to sin theta by cos theta. And in the same way, you can also prove that cot theta equals to the reciprocal of this, cos theta upon sin theta. Okay, so these two are known as quotient ratio, square relations. Okay, or we can say these are the identities, inverse identities, quotient identities, and square identities. So squaring is like if I take sin square theta, it actually means sin theta whole square. Okay, sin square has no meaning. Sin square theta means sin theta whole square plus cos square theta. We get sin theta is opposite by hypotenuse, and square of that, that's this. Okay, and cos theta is adjacent by hypotenuse, taking the square. Cos square theta is adjacent by hypotenuse whole square. So what do we get if we open the bracket? So that's LCM is h square and o square plus a square. Now if you see a right angled triangle, suppose this is the theta, then this is opposite, this is adjacent, this is hypotenuse. We know by Pythagoras theorem, we know that h square equals to this side square plus this side square. Okay, so the largest side is hypotenuse. The square of hypotenuse is equal to the sum of the square of the other two sides. This is Pythagoras theorem. Okay, so we can apply this here. Opposite square plus adjacent square is actually hypotenuse square. Okay, so we get 1. Okay, sin square theta plus cos square theta equals to 1. So even if you have 50° or 60°, theta is any angle you have, it doesn't matter. You can simply write sin square theta plus cos square theta equals to 1. This is the first identity of square relation. Okay. Similarly, you can prove the other two identities that we have. Second identity being 1 plus tan square theta equals to sec square theta, and the third identity we can prove it using this method simply by putting tan square theta equals to opposite by adjacent whole square. Like that you can prove it. And again 1 plus cot square theta, cot, okay, 1 plus cot square theta equals to cosec square theta. Now if you rearrange all these three identities, you get two more identities of each type. Okay, suppose sin square theta plus cos square theta equals to 1. We can rearrange and write it as, or we can write 1 minus cos square theta equals to sin square theta. So you can use any of these identities. And the second one rearranging, you get 1, this is the second one, 1 plus tan square theta equals to sec square theta. Now sec square theta minus 1 equals to tan square theta, or sec square theta minus tan square theta equals to 1. Okay, so the third one, 1 plus cot square theta, cot square theta equals to cosec square theta. That's if you shift 1 to that side, cosec square theta minus 1 equals to cot square theta. And then we have cosec square theta minus cot square theta equals to 1. So you don't have to remember all these 9, you just remember the first 3. What have we learned? We have learned the meaning of trigonometrical ratios, we have studied the different types of ratios, then we have studied inverse ratios relations, then we have quotient ratios relations, we have square relations. Now that's all. You need to remember this. Once you solve the questions, it will be easier for you to understand how to apply the particular identity in a particular problem. Let's see this question. Question number 1A of exercise 17. It says the figure is given. It's a right angle triangle. Right angle at R. This is the 90°. Okay. And you need to find the value of these trigonometrical ratios. These are ratios, okay, and two sides are given. So first we'll write what is given. Given we have PQ equals to 13 and QR equals to 12. Okay, and this angle PQR is given, angle theta. Okay, no need to write everything. Now to find all the ratios, we should know all the three sides. Okay, there are two methods to find all the ratios here. The first one I'm doing it right now. The second, or so let us first use Pythagoras theorem. To find the third side. Okay, using Pythagoras theorem we have This is the hypotenuse. Okay, we know that hypotenuse square equals to opposite square plus adjacent square, or in other words we know that hypotenuse square equals to perpendicular square plus base square. So that's 13 square, opposite is PR, and adjacent we have 12. So PR square equals to 12 square goes to that side, so 13 square minus 12 square is PR square. We have 13 square minus 12 square. So that's 169 minus 144, 25. And this is PR square, so that's 5 square. That means PR is 5. Okay. Once we have the third side, now you can easily find all the relations. Okay. So let's say sine theta equals to opposite by hypotenuse. So our opposite, now we have got it 5 and hypotenuse is given 13. Then we have cos theta equals to adjacent by hypotenuse, that's 12 by 13. Tan theta equals to opposite by adjacent, that's opposite is 5 and adjacent is 12. Now the other parts, cosec theta equals to hypotenuse by opposite, that's the reciprocal of sine, so 13 by 5. Sec theta is hypotenuse by adjacent, that's 13 by 12. And cot theta equals to adjacent by opposite, that's 12 by 5. So we are taking the reciprocal of this. Okay. Similarly, sec theta is the reciprocal of this, 13 by 12, and cosec theta is 13 by 5. Okay. Now this is one method. Let us see the alternative way to find it. It's very easy to find all the ratios using one of the ratios. So if you see the figure, we have 13 and 12, we don't have 5, right? So instead of using Pythagoras theorem, we can directly use this. So if we see the angle theta, what do we have? We have the adjacent side as well as the hypotenuse. Okay, so what is that relation we have? Adjacent by hypotenuse, that's cos theta, right? So that means we have cos theta equals to 12 by 13. Okay, now here comes to identify the identity you are going to use. So any of the identities that you can find using cos theta, we know that sec theta we can find. Sec theta is the reciprocal of this, adjacent, hypotenuse by adjacent, and that's 13 by 12. You see, sec theta. Okay, now what other things we can get? So we know cos square theta plus sin square theta equals to 1. We use that identity, sin square theta plus cos square theta equals to 1. Okay, from this identity we can easily find sin square theta. How? We'll just put the value of cos square theta there. Okay, so we get sin square theta equals to 1 minus cos square theta, that's 1 minus 12 by 13 whole square, 5 by 13 whole square. So sin theta equals to 5 by 13. You can also see that sin theta is 5 by 13 here. So cosec theta equals to 13 by 5. We can say it here. So if you remember, 1 plus tan square theta equals to sec square theta. Okay, so we already have sec square theta, we have sec theta, so 1 plus tan square theta equals to sec square theta. Now that's tan square theta, we need to find tan theta. Tan square theta equals to sec square theta, we get 13 by 12 whole square minus 1, that's 5 by 12 whole square, and hence tan theta equals to 5 by 12, and that also you have got 5 by 12. Similarly, cot theta is reciprocal of tan theta, so that's 12 by 5. Okay, so if you know one of the ratios, you can easily find all the other ratios using the identities, like square identity we have used, like sin square theta plus cos square theta. Then we have used reciprocal identities. In this question you are going to find the ratios like tan x cos y, but you need to be careful here, the angle is changing. Okay, so here we have x, here we have y, so we can see that this angle is x, this angle is y, and corresponding to the given angles we are going to find the given ratios. Okay, so ratios like in this triangle ADC is a right triangle, so we can find all the ratios related to angle x. Again, triangle ABT is again a right triangle, so we can find all the ratios related to angle y. Okay, let us first find out the ratios. To find that, let us take this triangle ADC. Triangle ADC is a right triangle, and which angle is 90 degree? Angle T. Angle T equals to 90 degree. So we can use Pythagoras theorem. Okay, so 13 square, 5 square, and this. So 13 is the hypotenuse, the side opposite to the 90 degree. Since the largest angle is 90 degree, hence the opposite side is the largest side, and hypotenuse, it's the largest side. So 13 square equals to 5 square plus AD square. Okay, we can find AD then. 13 square equals to 5 square plus AD square. We have taken right triangle, therefore we can use Pythagoras theorem. By Pythagoras theorem, okay, you need to write these things. You cannot just simply start like 13 square plus 5 square. Even if you write the whole thing, you might lose one marks here and there, so you need to mention why you are using. Okay, so AD square equals to 13 square minus 5 square, so AD equals to 12. We got our AD. So in this triangle we can find all the ratios now, since we have all the three sides. Now in the other triangle we are going to find the third side, that is AB. Okay, also here we have started with this, so that implies side. Now BD equals to BC minus DC. Okay, that's 21 minus 5, we get 21 minus 5, 16. Okay, so BD is 16, we got this side, BD 16. Now what is left? AB is left. The other triangle ABT is also a right triangle, and again angle T equals to 90 degree. Therefore you can write it using Pythagoras theorem. we have now AB is the hypotenuse. Okay, so AB square equals to BD square plus AD square, that's 20 square. Therefore AB equals to 20. Now we have got all the sides. So AB equals to 20. Now we can easily find all the ratios since we have all the sides. Now starting from the first one, okay, we need to find tan x. So what is tan x? This is the angle. Tan of x is opposite by adjacent, right? So for tan x, opposite is CD and adjacent is AD. Okay, so that's 5 by 12. You see how easy it is once you find all the sides. Then we have cos y. Cos y is we have angle y here. Cos is adjacent by hypotenuse. So for angle y we have adjacent as BD and hypotenuse is AB. So BD by AB, and that's 16 by 20. So simplifying it, we get 4 by 5. Okay, now the third one, cosec square y minus cot square y. That means cosec y whole square minus cos y whole square. So cosec y is inverse of cos y. Okay, oh sorry, cosec y is inverse of sin y. So sin y is opposite by hypotenuse. So hypotenuse by opposite you have to find out. For angle y, hypotenuse is AB and opposite is AD. So AB by AD. Okay, AB by AD minus cot y. Cot y is tan y is opposite by adjacent. So adjacent by opposite, that you get BD by AD. Okay, now square of that. So we get AB, how much? 16. Sorry, AB is 20. AD is 12. 20 by 12 whole square minus BD by AD 16 by 12 whole square. So you get 20 square is 400 by 144 minus 256. 16 square is 256 by 144. So LCM is 144. And you subtract, you get 144 by 144, that's 1. Erase this first part. Okay, let's find out the fourth one. 5 by sin x plus 3 by sin y minus 3 cot y. So you have 5 by, what do you mean by sine x? Sine x is opposite by hypotenuse, so for x you have opposite CD by AC, that's 5 by 13. Okay, so 5 by 13 plus 3 divided by sine y. Here also sine y means opposite by adjacent, hypotenuse. Opposite is AD and hypotenuse is AB. AD by AB, that's 12 by 20. Minus 3 cot y. Cot y is adjacent by opposite. Okay, you have to remember all the identities, all the ratios. So cot y is, if you remember that table, OA, OA, HH. So cot y is actually adjacent by opposite. So adjacent to y is BD and opposite is AD. So BD by AD we get 16 by 12. So 16 by 12. Now it's easy to simplify this. 5 divided by 5 by 13. So that's into 13 by 5 plus 3 divided by 12 by 20. That means into 20 by 12 minus 3 into 16 by 12. Okay, we could have cancelled. Whatever you get, 5 gets cancelled here in this term. This term you get 3, 4 and 4, 5. So you have 5 left here. 3, 4 and 4, 4. So what do we have? In the first one we have 13. Second term we have plus 5. And the third term is minus 1. Sorry, 4. So that's 13 plus 5, 18 minus 4, 14. Okay, so the fourth value comes to 14. That's how you find it. That's all for now in this class. I hope you have understood all the identities, how to use them, and we'll do some more questions from this exercise in the next class. See you in the next class. Thank you.